Hello, welcome back to the Marchanaut Show, the tech show about hacking. In this video, I'm gonna go over Procmon, and we're gonna use it, right? I'm gonna give you an overview of how to use it to determine if your PC is hacked, right? This is a concept called process forensics, okay? So without further ado, let's get right into it. We are going dark. So let's start with this little overview. So Windows internals and the Win32 API, before we start, the journey into Procmon, I think, let's take a little detour and understand what happens when a process tries to request something from the OS by taking a look at some internals. So Windows segregates user operations and OS operations by what is called the user space / user mode and kernel space / kernel mode. User space will contain everything ranging from applications, services, system processes like the service control manager, sessions manager, and everything that the user will execute. Whereas the kernel space will handle everything related to memory, drivers, file system, I/O, etc. So let's say we have an application and we call it application X. In Windows, this application will be represented by a process in user mode when it runs and will possess at least one thread of execution. Our process will want to do something at one point in its lifetime as good as the process should. It could write / read a file, access the network, draw something on the screen, and so on. All of these actions requires the process to interact with the kernel, as it is the sole responsible for all, including system resources. To do that, our process will need to use the Windows API. For the purpose of this discussion, we will not care in what language our application is written. Instead, we will only focus on how the system will handle the request. So let's say that our application wants to write a file and calls the appropriate functions in its code. Windows will call eventually the API function that is responsible for writing files, namely the write file, and from the kernel 32.ll, which is the user mode DLL that contains the Win32 base API and our write file function. But as we said, kernel 32.ll is still in user mode. That means we still need to go down. In truth, the write file function is just a wrapper that will check the parameters being sent and call another function in another DLL named the ntdll.dll, right? So that nt.dll.dll is the lowest point we can reach in user mode, and it's the DLL implements the undocumented Windows API and the one responsible for the jump between user mode and kernel mode. So continuing with our example, the function that will get called from the ntdll.dll is the ntWrite file, which will be the one responsible for the switch from user mode to the executive in kernel mode. So I'll spare you what will happen in the rest of the journey of the thread. Safe to say, we will get back from the kernel into our original calling function with our file created. So there's going to be a diagram illustrating, what we talked about in an abstract way, okay? So this example can be generalized to illustrate what happens every time an application requests a resource from the kernel. An application wants to do something. By calling the appropriate function in its code, right, the reading / writing file, printing a document, communicating via the network, etc., that function will at some point call the appropriate subsystem DLL, all right, which is the kernel 32.dll, the ws2_32.dll, etc. That subsystem DLL function will check the parameters and that everything is good to go, and will make a call to the native API corresponding function in the ntdll.dll. The ntdll.dll will then pass on the rest of the work to the kernel, and stuff will happen. If everything worked perfectly, we should get back from the kernel, okay, a return to the caller and continue the rest of the program. Now that we have understood a little bit about how to process and execute something, now it's time to dive into the process monitor, right? The Procmon. Okay, so this is where we get into the nitty gritty, okay? So in our case, we're interested in using Procmon and its functionalities to hunt and understand what malware is actually doing. The files it's creating, the registry keys it's modifying, the network communications it could be having, and so on. Once we start Procmon, it'll start capturing events immediately and will be greeted by an interface that contains the following information by default. Right, the time of day when the event occurred, the process name, which is the name of the process that executed the action, the PID, which is the process ID, the operation, which is the name of the operation that occurred, and then we have the path used by the operation. It could be a registry path, a path file, or a network communication. The result, which is the result of the operation, details about what happened during that operation. So let's discuss how we can use the information gathered by ProcMon in our hunting and analysis. So process, monitor, filters. Because of the sheer amount of data that ProcMon captures, one of the key features to master is filtering. Filters become a necessity to anyone using this tool, and especially when analyzing malware. ProcMon offers a ton of filters, but for the sake of our sanity, we'll be focusing on those that often use a malware analysis. So operations, right? Every action captured by ProcMon is associated to an operation. There are more than 170 operations that we can filter on. Generally, when doing dynamic analysis of malware, we're interested in knowing what files and registry keys are being created, deleted, and modified, what network activity is happening, and what DLLs are being loaded, and so forth by the malware. The following operations are the most common operations performed by the malware and are the ones that we should filter on during analysis. The create file, when a process wants to create a file. The write file, when a process writes data to a file. Set rename information file, which is when a rename operation occurs on a file. We have the set disposition information file, which is when a file deletion occurs on the file. We have the reg create key, when the registry key is created. The reg set value, when the data for value is set in the registry. Reg delete key, when the key gets deleted from the registry. Reg delete value, when a value gets deleted from the registry. TCP connect, TCP receive, UDP send, UDP receive, which is the process is sending / receiving a TCP or UDP connection. Load image, when a process loads any DLLs / executables. Process create, when a process creates a process. Create pipe, when a process creates a pipe. You can access the filter functionality from the toolbar menu or by pressing Ctrl+L. So the ProcMon filter view, I've compiled all of these operations into one giant ProcMon filter that you can use during your malware analysis. Here is, you can go on Google and put the link to download. We have the NAS bench / ProcMon malware analysis filters, right? The repository containing malware analysis filters for the Windows system internals. Process monitor tool GitHub is home to the github.com. So next on our list of features is highlighting features, same as filtering, but this time instead of removing or including unnecessary events, we can highlight those that we only care about. This can be useful when we want to highlight a particular file, a path that is of interest to us. We can use this feature by selecting it from the toolbar menu or pressing Ctrl+H. The process tree view. One of the cool features of ProcMon is the process tree view. It will show every process capture in a trace in a tree-like view representing the parent/child relationship between them. This can be extremely helpful when analyzing malware that spawn processes that dies quickly. For example, we can launch a trace and then execute our malware and let it run for a while. This sample could launch the cmd.xce, the PowerShell.exe, or even create other processes, and we wouldn't even notice, but ProcMon will. When we feel like the malware ran for enough time, we can then stop the trace, navigate the tree view, and visualize every child of that malicious process. We can then include the process itself, all of its children, and navigate to the first event it executed. So we have the ProcMon process tree view, and this is a conclusion, right? ProcMon is a very powerful tool for malware analysis. It lets us see the unseen and uncover the many hidden layers of a process or an application. So what do you think about this video? What do you have any comments? Do you have any opinions? Please let me know. Please like the video. Please share the video. Please hit the subscribe button. Please hit the notification bell. I love you. Stay safe. See you on the next video.